Okay, again really quick, the very first thing you do when you factor is pull out a GCF, right? Then you look to see how many terms they have. If there are 4 terms, you factor by grouping, right? After that, you look to see if you have trinomial. If the leading coefficient is 1, you do what we just did. If you can factor out a GCF to get it to be 1, you play the game. What happens, though, if it doesn't have a greatest common factor? So that's the last step that I need to teach you today. This is very, very similar to basically what we're doing is we're playing the game, we're factoring by grouping, and we're merging them together. So I want you to just put down your pencil and watch part A, and then I'll let you copy it down, and then I just don't want you to miss something because you're looking up and looking down. So we are going to start by playing the game, just like before. Now everything we've done so far, this leading term has been 1. So when I'm asking to multiply, I really only care about that last number, right? In this case, however, my leading term is not 1, it's a 5. So when I'm looking for the multiply part, I need to times those two together. I'm looking for 2 numbers that multiply to 15 and add to 16. So really quick, one more time, where did the 15 come from? From the 3 and the 5. Where did the 16 come from? From the middle. So, on your own, what 2 numbers multiply to 15 and add to 16? 15 and 1. Now it would be really tempting to just go b plus 15. This is why you're not writing it down, right? This is not right. It would be really tempting just to put those numbers in here. But if I were to re-multiply this back out and undo the factoring process, I would get a b squared, right? I want to get a 5b squared. So this is not right because I wouldn't get the 5 where I needed it to be. So you have to do something else. You have to do something else. We are going to look at these terms as a 15x and a 1x. Now this 15x and this 1x, sorry, I changed variables. This 15b and this 1b, if I added them together, wouldn't I get the 16? So I'm going to change the way this looks. I'm not going to change the value of it. I'm just going to change the way it looks so that I can do something that I already know how to do. I'm going to split up that middle term, and instead of saying 16, I'm going to say 15 and 1. Now that still is 16, right? But I've split apart that middle because once you have it split, we have 4 terms. And do we know what to do with 4 terms? We can do what? We can group them. So it does take longer when that leading term is not 1. Technically, I was supposed to show you how to do it this way every single time. I showed you the shortcut when it was equal to 1 to cut down on time because it was a short day and we were running out of time. So I showed you the shortcut, and now I'm going to show you like how you're actually supposed to do it. But you can use the shortcut on the ones that we already know. Is that okay? Are you okay with the shortcut? Okay. But if that first number is a 1, you can't take a shortcut. Now I've grouped them. Looking at the first group, what do they have in common? A 5 and a b. What's left inside? The 5 comes out, the b comes out. B plus what? B plus 3. Looking at my next group, what comes out? A 1, nothing comes out, so we're just going to say plus 1. What are we left with? Nothing came out, so b plus 3. They both have a b plus 3, right? So what do I do with it? Take it out front. This disappears and this disappears. So what are we left with? Good. Now the question often comes, what happens to this 16 and this b? Now, if we were to multiply those two and multiply those two, do I get the 16b when I added them together? That's where the 16b is. It's here and here. We've just kind of sifted it apart. Does that make sense? Okay, this is your final, and we ripped it apart, yeah. So it's just an extra step. Yes, write it down, please. Yes, sir. Yes, please. Go ahead. No. Savannah, go ahead.
Okay, so like the 15B is now like the 15.
And then one.
Okay, the 15 and 1.
Yes. Yes. Susanna?
So, what about the 5 plus 1 and then
No, you could, like this order right here could be switched. Yes. Something else to note, this right here, I did 15B and then the 1B. You could also do the 1B and then the 15. The order there doesn't matter. If you switch these two around, then this step looks different, but your final answer will be the same. So those can be flip-flop. That's what I was trying to say. Okay, let's try it again. Part B. On this one, is there a greatest common factor? No. So we are looking for two numbers that multiply to what? Multiply to 36 and add to negative 20. On your own, don't yell it out. See if you can find those two numbers. I'm going to give you 30 seconds. See if you can find them. And if you don't know, just try plunking numbers into your calculator. Try 1, try 2, try 3, try 4. There's a lot of numbers that go into 56 or 36. All right, what do you think? What multiplies to a 36 and adds to a 20? 18 and 2. Good. And they both are? Good. Now what do I do with those two numbers? I'm going to take those numbers, 18n, 2n, and do what with them? Split up that middle term. So we will rewrite it. 3n squared. Does it matter which one comes first? Does not matter. So let's try minus 2n minus 18n plus 12. And then just double check. If I were to add those together, I get the 20, right? Now we're going to factor by grouping because there's 4 terms. This one, though, has a negative in front of the 18. That negative needs to go with the 18. Remember that? Don't confuse this with a multiply. There still is a plus in there. I just lost it when I moved the 18 over. All right, looking at the first group, what do they have in common? An n, and we are left with 3n minus 2. Looking at the second group, what do they have in common? A 6, but I'm not going to pull out a 6. I'm going to pull out a negative 6 because this right here is negative. If I pull out a negative 6, 18 divided by 6 is 3n. And then will it be plus or will it be minus? And how do you know? 3n minus, why is it minus? Divide by a negative, right? Positive divided by a negative is a minus 2. Do they have the same thing, that matching pair right here in parentheses? Yes, so I'm going to pull it up front. And what's left? N minus 6. So initially our plan was to hurry and fit this in at the beginning of class and then move on to imaginary numbers because really imaginary numbers are going to be really quick. It probably will take us 20 minutes to do imaginary numbers and it will be done. But I felt that factoring was so important that it would be worth taking an entire extra day on it. So on the back it says my test is on the 8th and the 9th. It actually is going to be the 10th and the 11th. We'll move it back a day. Okay. Why don't you try part C? See if you can fill out the chart. See if you can find the two numbers. I'm going to pause it really quick. Don't forget to remind me to. All right, we're looking for two numbers that multiply to what? Negative 90 and add to a 13. Now negative 90 is harder, right? The bigger the number, the harder it's going to be. So if you need to, just start listing and always start, 1 in 90. Very rarely is it going to be 1 in 90. But by starting with 1 and just kind of continuing up, eventually you'll get all of the factors here, and then you'll be able to find one of them that will work. So 2 and 45, 3 and 30, 4 does not work, 5 and 18. Anything else? 9 and 10. You can stop once you find it. You don't have to list all of them. Which one of those would give you a 13? Which one's negative? Good. So what do we do next? Minus 5p plus 18p minus 15. Did anybody flip those if I'm in a reverse order? That means this next step is going to look different than my next step because the greatest common factors will be slightly different, but your final answers should be the same if you did it right. So grouping it, looking at the first group, they both have a p, right? What are we left with? 6p minus what? 5. Looking at the second group, they both have a 3, so plus 3, we are left with 6p minus 5. They both have a 6p minus 5, so we will bring that out front. And if you flipped them, then they both would have had the p plus 3, right, on here. What's left? From here, p, from here, plus 3. So again, if you flip-flop these middle ones, then your work would be kind of reversed. The p plus 3 would be on the inside, and the 6p and the minus 5 would be on the outside. The final answer ends up being the same. How do you feel about it? 1, 2, 3, 4, 5. 5, I got it. 1, I really wish I was here on the most important day of the school year. 3, 4, 2, 1, 2, okay. Do another one. Part D. Try it on your own. See if you can get it. All right, number 6, we could stop there and be done. But number 6 is a shortcut that you could use or you could not use. The shortcut is called the difference of squares, and it's just a pattern that happens every single time. You may have noticed it already. But if your polynomial has two terms that are both perfect squares, so yeah, this one is a perfect square and that one's a perfect square. 4 is perfect, g squared is perfect. You can separate, and separated by subtraction, so it would look something like that. You can factor them. Okay, it's really hard to read math. So what this means is only when you're subtracting. If that was a plus, then it would not factor. You couldn't do it. All right, so for part A, z squared is a perfect square, right? Z times z. 9 is a perfect square. 3 and 3, right? So if you have a perfect square and a perfect square with a minus in between, you could go straight to, it's fun. Take the square root of the z. It goes here. Take the square root of the 9. It goes here. And then one has to be negative and one has to be positive. Now we've done this before. When we set up our little chart, it would have to multiply to the negative 9 and add to 0, right? 0 because there is no middle term. Do these multiply to negative 9 and add to 0? Yeah. So do you need the shortcut? No. You could play the game and you could get it. The shortcut's just nice. It makes you do it faster. Let's look at part B. Do you have a perfect square here? The y squared is perfect, but the 2 is not, right? What about the 32? Is it a perfect square? No. So as it stands right now, you couldn't do the difference of squares. But is there a greatest common factor between those two? Yes. Pull out the factor first, and then what are we left with? Do we have a perfect square, and a minus in between? Once I pull out the 2, is it a difference of squares question? Yeah. So because of the perfect square, and the minus in between, ignore the 2 for now. You're going to have y, square root of 16, 4, 4. 1 has to be negative, 1 has to be positive. And then where does the 2 go? Outside. Again, not necessary to learn the difference of squares. Makes it a little bit faster. You don't have to really play the game. What about part C? Is there a GCF on part C? Yeah, it's a lot of 4. Then you have g squared minus 16 on your own. Please figure that out. So look for perfect squares. It makes the problem faster. G what? Plus 4. G what? Minus 4. And where does this leading 4 go? Outside and inside. Okay, that is the end of part 2.